All right, let's dive into something that feels like it's pulled from the bleeding edge of science fiction. We're going to explore a framework for a new kind of evolution, one that happens entirely inside a computer. It's this incredible vision for simulating superhumans and even inventing totally new forms of matter. Let's get right into it.
So let's just start with a big question, right? What if we could actually design the next step for humanity? It's a huge thought, but it's the absolute core of this speculative framework, a plan to model the future of our species, not in some messy lab, but inside a massive physics-based simulation. And before we go any further, let's get one thing crystal clear, because it's the most important rule of this whole system. We are not, I repeat, not talking about genetic engineering or messing with actual biology. This is all a thought experiment, a simulation running inside what the source calls a spectral computational universe. Which leads to this really crucial idea. Before you can even think about simulating some kind of enhanced human, you have to build the reality it's going to live in from the ground up. You need a universe with its own set of physical laws, its own building blocks, and its own engine for evolution. And this brand new reality is the setting for the first major goal of this framework. It's a huge project they're calling superhumans, and the aim is to create digital twins of what our species could potentially become. So the idea here is to build these incredibly detailed digital twins. We're talking simulations that model everything from the atomic level all the way up to a whole organism. And these aren't just abstract ideas. They're meant to be physically grounded, which is just a way of saying that every single part of them has to play by the rules of the simulated physics.
And you can see just how ambitious this is when you look at the roadmap. Gen 1 is basically a better version of us, more efficient, way more resilient. Gen 2 kicks it up a notch with seriously enhanced thinking and senses. But Gen 3, that's something else entirely. It's a model of a human with almost perfect internal harmony, a mind that's practically immune to distraction and noise. Okay, so if that's what they're building, the really interesting question is how. How do you actually evolve these digital beings? Well, you can't use old tools. You need a totally new kind of evolutionary engine. And that engine is called genosynth. It's the powerhouse behind what the source calls living artificial intelligence. Now, the key idea here is what's really wild. Instead of evolution being about random mutations and survival of the fittest, this is about resonance coherence. Basically, the patterns that are the most stable, the most harmonious, and the most physically efficient, those are the ones that get to survive and reproduce. And this comparison really shows you what a massive shift in thinking this is. The AI we're used to is Boolean. It's all about zeros and ones. It's abstract. It's often just brute force calculation. But this living AI is totally different. It's based on resonance, on physical waves and oscillations. It's designed to be self-organizing, with physics as its ultimate rulebook. You see, the building block for this new life isn't DNA. It's something called rDNA, a resonant genome. The best way to think about it is less like a biological code and more like sheet music for a vibration. Its codons aren't genes, they're physical properties like frequency and phase that define the entity's core resonant pattern. So what does this digital Darwinism look like in action? Well, it's a loop. It starts when an entity senses its environment, and that data gets encoded into its resonant genome. Then that genome is simulated. Now, the entities that are the most stable and coherent, the ones that vibe best with the laws of physics, you could say, they get selected to stick around. And finally, controlled changes to their properties create variety for the next generation to start the cycle all over again. Now, if you have an engine that powerful, you better believe you need a strict set of rules to make sure it operates safely. And that brings us to the core philosophy that governs this entire system. The source material uses a very specific term for this philosophy, Neugenics. But, and this is really important, it's completely redefining it. In this world, Neugenics is the science of synthetic evolution. It's a computational framework for designing systems that can adapt and evolve based purely on the physical principles of resonance and coherence. And this whole thing runs on 3 absolutely non-negotiable principles. First, evolution is driven by resonance, not just survival. Second, everything, and I mean everything, has to obey the laws of physics. And third, the biggest rule of all, this is simulation only. There is a hard firewall in place that prevents any of this from ever being translated into real-world biology. Period. So, how do you enforce that second rule?
You do it with something called the physics of physics operator, or POP for short. Just think of it as the ultimate reality check for the entire simulation. It's like a physics judge that's constantly watching everything. And if any evolution starts to create something that's physically impossible or unstable, POP shuts it down instantly. No exceptions.
Okay, so let's pause for a second. If you have a system that can evolve synthetic life based on physical laws, what else could it create? This is where the whole vision just gets even bigger.
Because this vision goes way beyond just life. The framework proposes a direct counterpart to that biological engine we were just talking about. So while genosynth is busy evolving organisms, a second engine is designed to evolve actual matter itself.
And this table just lays it out perfectly. On one side, you've got genosynth, evolving synthetic life with rDNA, and its star application is Project Superhumans. Then on the other side, you've got its twin, Neutron Alchemist. It evolves new atoms and materials using a similar idea called an atomic spectral tensor, all with the goal of discovering incredible things, like maybe new kinds of superconductors.
So let's bring all of this together. What is the ultimate endgame here? What does this future, a future built entirely on the concept of resonance, actually look like? Well, the grand objective is to create a single, unified computational universe. It's called the Universal Spectral Entities Constellation, or USEC. Inside this shared reality, the synthetic life from genosynth and the novel matter from Neutron Alchemist can live side by side, and this is the truly amazing part. They can even co-evolve together as these deeply intertwined resonant patterns. And all of that leads us to this final, really powerful statement from the source. This whole project isn't about building an AI that's just a clever copy of life. The ambition is to create a system where computation and intelligence are actually real manifestations of physical coherence. In other words, a new form of life altogether. Which, of course, leaves us with one last mind-bending question to chew on. If a simulated universe with its own rules of physics can create evolving life and matter that are completely real and consistent within that universe, well, what does that say about our own definition of reality? Definitely something to think about.